So folks, once again, just letting you know that this will be recorded and then later on published on YouTube. Just a reminder that now I'm sharing my screen so I cannot see the chat. This is our first webinar of the year. And just one more minute before we kickstart things. I see some of the folks who have joined. This is like, I'm sharing just a fun fact or an interesting fact. Some of the folks who joined us today are past Outreachy interns or have been Outreachy applicants with us, and that's really cool because we can see this community who is growing, and I personally get very happy and a bit emotional about that because that's how my journey with Suricata started as well. Okay, so 2 minutes. If I get a bit confused, it's because I'm trying to introduce the webinar and admit folks as they join, but everything will work. So as I said, this is our first webinar of the year, our first Suricata webinar of 2023. Our guest is Haleema Khan. She was an intern with us via Outreachy, and she will be talking about her internship with us, her project, and which was about frames, adding frame support, and also boosting our code coverage. As usual, this webinar is brought by OISF and Suricata. OISF is a US 501c3 nonprofit organization. And if you want to know more about it, or if you want to support Suricata and OISF mission in supporting Suricata, you can get to know more at oisf.net. Suricata is maintained mainly by consortium members because, as you know, we are open source, but this doesn't mean that it's free to be developed, right? And that's how OISF is able to keep our amazing team of developers and other folks who make things work. I've mentioned as well Outreachy. And what is Outreachy for those of you who are not familiar with it? This is an initiative that provides paid internships in open source and open science for folks who are underrepresented in the countries they lived in. And as I said, they are paid, they last for 3 months, they are remote, and they run twice a year. They are open for students, non-students, returnships, people who are changing careers. How much experience is needed varies from project to project, but it's usually a place for one to learn. So not a lot of prior experience is necessary. And if you want to get to know what open source is or get your career started with that, or getting to know more open source communities, this is a great way. This is great for folks who would like to participate, but it's also very interesting for communities, particularly with OISF. It's been a very, a great experience. Overall, we have had many great interns. I am one of them, very humble, I can say. But we also had Vagisha, Tarushi, Halima, who is here with us today, Sam, who is also attending, and Modupe. And I think it's a great learning journey for everyone. So if you want to know more, outreachy.org. If you want to join our Suricata community, ask questions, or interact with us, you can join our forum, forum.suricata.io, or our Discord server. For questions, it's best to use the forum, but to hang out or more quick help, Discord will also be there. We have our site where you can check for trainings and webinars and whatnot, suricata.io. And if you follow us on Eventbrite, you will know whenever we have a new webinar or our conferences or anything that is going on. Also follow us on Twitter. It's where we are mostly active lately. And a bit about Haleema Khan. I'll let her introduce herself, but I just wanted to let you know that she was, as I said, our last Outreachy intern. She's from Pakistan. She has been amazing since the application process with Outreachy up to the contribution phase where she helped others, and she really got the idea of what is to be a part of an open source community. She has worked not just with one but two projects during her internship. She is maintaining a blog where she shares about the technical challenges that she has had, and where one can find, for instance, how to run Suricata on macOS, or how to run your code coverage locally, which is something that is not necessarily easy. So I do recommend, if you want to see how to solve those challenges, to check Halima's blog. Please, Halima, the floor is yours. We are very glad that you made time to be here with us, even after your internship ended. Thanks a lot for all that you have done. And please have a great time with us today.
Thank you so much. Thank you so much, Juliana, for the kind words and introduction. I'm glad to be here today. I'm glad for the opportunity to be here. I'm just sharing my screen. Let me know as...
Yes, it is working. I'll just stop my video and I'll mute myself.
Okay. Okay. So, yeah, Juliana has pretty much introduced me, but I would just like to start with a small intro. So I am Haleema Khan. I am based in Islamabad, Pakistan, and I'm a software engineer by profession. So before Outreachy, I had about like 2.5 years of experience, but all of that experience was based in the integrations domain, where I mainly worked with middleware tools and platforms. So one of them is Mulesoft. So mostly my work in the integrations domain is based on Mulesoft. So I'm also a Mulesoft mentor in the community as well. And apart from that, when I'm not working, I like reading books and I like to travel and cook when if I get time. But I really don't get a lot of time for cooking. But yeah, that's that. Apart from this, as far as my research interests are concerned, I'm really eager to learn more about cybersecurity tools and how they intersect with the systems domain, so that we can make these cybersecurity tools better. Like, for example, Suricata is one of the tools, but there are others too. So how provisioning different like parallel techniques can help these tools. So that's one of the research area that I'm really, really interested in. And moving on to my Outreachy journey. So Juliana has pretty much summed up what Outreachy is and how this works and what's the process and all of that. So I'll just be talking about how it really was for me. In the last year, when I actually started preparing for Outreachy, I was an absolute beginner to the open source world. So this was something that I really got scared of, because in my previous work and jobs, I was not actually writing full-fledged applications based on one programming language. So I thought, to be able to contribute to any organization, I need to be able to write some code, be at a level where I can write those applications, and I was clearly not at that level. So I just thought that, okay, this is something that is really scary and tough, and I won't be able to do it. So I just gave my this task that, okay, let's try and let's prepare for it. So I just started preparing for the contribution period and the application period, and I started learning about how this open source world works and how to contribute and what are the organization. When I got accepted, my initial application got accepted, and I started looking out for the organizations that I wanted to work with. I got really, really overwhelmed because all of the projects seemed really specific. That's the purpose of them being there, like they are specific in the domain. So for them, I needed to have some expertise or knowledge in either, Python or C or Rust or React or Android. Like, I'm talking about all the other organizations that were part of Outreachy. And it was another thing that was a big hurdle for me, because I had absolute zero experience in any of the languages that were listed there, because I've worked with integrations. In integrations, you work mainly with enterprise clients and enterprise platforms. So they're mostly low-code environments. I have worked with API development, but that's also very different from what was there. So I was overwhelmed and I was scared. And with this mindset, I started joining different communities. So one of them was OISF at that point, and I did not think of applying to this project in the start, mainly because I just used to find it really, really scary. Mainly Rust, not Suricata, because at that point I did not even know what this is. But like, just looking that this is in C and Rust, it was enough for me to get scared. But then I joined the community, and I think the main thing that made me choose this community and work for it day after day was how approachable the people were, how the whole community was talking to the participants and helping them. I joined the Discord server, and I remember messaging a lot of channels that I'm an applicant and I need help with this and that. And I remember random people helping me build my code on Mac, and like, even when I was not expecting an answer, I was able to find someone who was kind enough to give me long explanations. I remember there was one time when I had asked a really stupid, not really stupid, but something that was very basic. And then the next day, one of the mentors, Shivani, gave me a really, really big explanation on it, and I felt really bad that, okay, this was not supposed, like, this was supposed to be really easy. And but the community was very, very approachable, and they made me feel at home. And then that I ended up submitting applications for all the projects under OISF, and that's how I am here today. So yeah. And then another thing that is a really, really big achievement for me is being able to say that I worked with a project which is entirely based in some coding languages, and I was able to do that. And then at the end of the day, I have I was able to complete the tasks of my projects. But apart from that, I learned the importance of consistent effort, and this is like the biggest takeaway of this whole process was for me. So now moving on to my actual project. So Suricata is actually it's a basically network monitoring tool. So it can be used in a lot of modes, like intrusion detection mode and IPS mode. And then apart from this, there are a lot of things that can be done with it, like packet logging, packet capture. Then it can be used to extract files from the ongoing traffic, and then extract certificates, SSL certificates. So it is far more than an IDS and IPS. So my project was based, like, I worked on multiple things. So one of the projects that I'm going to talk about is the frame support. So it was basically based in the Rust part of the code base. And so I'll start with trying to explain what adding frame support means. So adding frame support is basically being able to tag various portions of the application layer so that they are available to the detection engine for easier processing. So basically what a frame basically represents a small unit of data that a person annotates within a stream, and then once that is annotated, it is available for anyone to use as is. And what it will accomplish is, one, that it will make the data processing time for the processing time for the engine better. It will improve it. And the second thing is, so when the rule writers want to extract certain content from a network stream, they will be able to use those tags, which are also known as frames, and it will be easier for them to extract some content that is important to them. So before that, if there are no frames and the person who is writing a rule is trying to extract the content, they will have to specify a lot of details like the depth, offset, because it's like they have to go really, really deeper into the hierarchy of the protocols to get to a point where they can extract that content. But now, after frames, they can easily take this tagged portion and just say that, okay, we need this, and it will be available because it is annotated. So I will be talking about two of the protocols which I worked on during my internship. But before I move on to those, I will just briefly explain what steps are necessary, what steps are important to adding frame support in any protocol. And these are identical for all of the protocols, only a few difference. So for adding frame support to any protocol, one thing that is really important is to understand the package structure of whatever protocol that you are trying to work on. So you will examine the packet, you will see what the data is, and then after the data, the most important thing is coming up what frames you want to make for this certain protocol. So these frames can be as generic as header frame, data frame, PDU frame, or they can be specific to what you may need, or what might some rule writer need in order to extract some important piece of information. So for example, if there is a protocol and based on the popularity of the use cases that many rule writers may come across, they may need a frame, or a frame might be important, which may not be available in all the packets, for which the data is not available in all the packets. But since it is an important piece that gets used a lot, we might make a frame out of it. So different steps, speaking of the code, basically include just defining those types, frame enum types. Once you have decided about the types and number of frames you want to make, then next part is registering those frames at the specific points within the code. So that's how they will be parsed. Otherwise, if you register the wrong frame at the wrong spot, then it will be a mess. And then finally registering the callbacks, and there is a frame API that can be used to build on, or that can be used, or that can be used to add more logic to it to register the frames. So now I'll be talking about the two protocols I worked on. The first protocol is the RFB protocol. RFB stands for Remote Frame Buffer Protocol. So if any one of you ever has used a remote desktop connection, then this was the protocol that was underlying this remote desktop connection. In this, the person using the remote desktop is the client, and the remote desktop which you are controlling is actually the server. So that's how the client server communication starts. And the RFB protocol basically has a bunch of messages that gets exchanged between the two, and then the video frames are exchanged, the pixel frames of the remote desktop, so hence the name Remote Frame Buffer Protocol. So for this protocol, I registered one frame which was called PDU, protocol data unit. PDU is basically the smallest unit of this app layer that can be made. There might be further divisions to it based on what the packet structure is, and as I mentioned in the previous slide as well, that which frames make sense in terms of use case wise or security standpoint. So after those decisions, PDU frame was registered for RFB, and this snippet basically shows how the enum was registered in the code. And here this is a snippet of how this frame was registered within the code of this protocol, like where was this frame actually registered. So right after the parsing function starts and a state is parsed in RFP, PDU is registered. So PDU is basically the whole RFP unit, so the protocol data unit. Moving on, next is the MQTT protocol. So MQTT stands for MQ telemetry, and it is a standard messaging protocol for the Internet of Things. So if you have maybe some smart lights at home or smart door alarm or something like that, and then these devices are communicating, and then they are also communicating with the central hub and passing messages and all of that. So this is a protocol that is in action when this happens. For MQTT, I registered 3 frames, the PDU, header, and data. I'll come to the why portion later, where I will explain why these frames were registered, but this is the enum in the snippet. And moving on, this is the function that basically registers the header and data frames in one function, and then this was called multiple times within the whole code base of MQTT to whole code of MQTT to basically register those frames at the appropriate times. So this code basically shows how you can build on the current frame API to add a bit of logic or to manipulate it a bit. Almost all the things are passed as is, but there's a bit of manipulation where a different length or where a data stream is getting passed. Moving on, so right now I will be comparing these 2 frames only in terms of what kinds of frames were registered. So these snippets are basically PCAPs of Wireshark. So these are packets of all the 3 protocols, MQTT, and then the 2 snippets are for RFP, which is also known as Virtual Network Computing, VNC. So as I mentioned before, only PDU was registered. This was because it was in these 2 snippets, one represents a server protocol version, the other represents authentication response. So in both of these, it shows that there are no commonalities between these 2, and then even in all of the other RFP packets, each message was an entirely different thing, and they were basically representing standard client protocol, so client server session initiation packets, like, okay, this is the server protocol, this is the client protocol, this is my authentication type, okay, and then they were passing. So there was no nothing that could one, be categorized in any way, and 2, be important in a way for someone to be annotated. Like there was no point for us, like, in annotating the maybe server protocol version or anything, because they were just standard messages. So that's why only PDU was registered. But if we look at MQTT, it is very evident from this packet that there are certain header flags, and there is topic length, topic, and other data. So for this, you can say, like, stage 1, the 3 PDU header and data frames are registered, and this is something which is not final or like the last word for these protocols. So these can always be revised, and more frames can be added that make sense or that can be important use case wise. So for now, if header, data, and PDU frames are there for MQTT, there is also room for other frames to be registered, and more annotation can be added to MQTT to make it easier for anyone to get any specific data that may be necessary, but like this decision is not dependent on just one person, because the whole community is taken into account, and the usability of the whole tool is taken into account when it comes to decisions like these. So that's about it for the frame support part. And I would also like to mention that if anyone wants to learn more about these, there's another webinar by one of the past Outreachy interns with Suricata. So it's available on YouTube. It was given by Sam Mohammed. So she discusses the NFS and overall frame support in detail. So anyone could refer to that too if they need more insights into the whole process. Moving on. I would now like to talk about testing in Suricata. So testing, like we generally know, is about making sure that your code is working fine and writing tests for different portions to make sure they are working as expected. So I worked with two kinds of testing mechanisms, the unit tests and Suricata verify tests. Mainly it was done to improve my learning of the code base, because when I started my internship tasks, it was something like adding frame support made no sense to me at all. And then when I was assigned these protocols made no sense to me at all. So just to get to a point where I am comfortable with them and understand what they're trying to achieve, because you cannot register frames for something that you don't even understand. So to understand them, I started with unit tests and Suricata verify tests. So Suricata verify is basically a tool that is available and written specifically to test various behaviors within Suricata. So it's a separate tool, but you have to run it on the Suricata code base to make sure that different portions are working as expected. So you will be able to see outputs just like a unit test, but I think somewhat more complex to run or visualize if you are new to this. So this is a unit test, which is like very simple. We're just comparing the expected or actual output of a simple function. So simple assert equal statements, just like in any other language. But when it comes to Suricata verified tests, this is a small representation of how a test might look like. Like I have tried to represent one test for ICMP I-type here. And when there is a Suricata verified test, the bare minimum things which are needed are basically an input file, which is the PCAP. It is an actual PCAP network that is extracted from a network, or you can even make one using various tools. But this is the one thing that is absolutely necessary. The second thing is having a rule file, and the final thing is the test YAML file, which is basically the final match criteria. So here, if we look at the PCAP basically is tested against the test rules. So for all the I types are matched. And then when we come to test YAML file, if I just try to explain the first check, this first check basically says that if you are able to get 75 alerts or alerts on 75 packets for signature 1, which is the rule 1, then this test will pass. So this is one of the criteria in the test YAML file, and obviously for the whole to pass, all the checks should be passed in it. So at the end, if this test passes, it means these criteria are being met and as per the rules. Next, I'll be showing a local demo of how testing. So this is basically a representation of how you can run this tool. And to be able to run the Suricata verify tool, you should be in the Suricata directory. And then from the Suricata directory, you have to call the run.py file, which is which executes those tests. And after that, there is a pattern that needs to be passed. So I'm passing TLS here. This pattern will basically match all the TLS related tests, and then run those. And okay means they were running successfully. So at the end, you will get like a report of how many passed, how many failed, or how many were skipped. So these are for HTTP. And one more thing, you can even try to run the whole Suricata verified directory and run all those tests together. Okay, just why is it stuck? Sorry for that. Somehow it is just okay. So moving on. So now I'll be talking about the second most like this is one of the most, you can say, new things for me when it comes to my work in Outreachy, because like I talked about writing tests, I talked about writing unit tests. These were the things that I got to work and learn about them during the contribution phase too. But this is something that was entirely new for me. So code coverage is basically shows which portions of the code are covered by tests, and that tests basically tell that okay, the portion of these portions are working fine. So code coverage reports basically show how much portion of your entire code base is working as expected. And then there are a lot of code coverage tools that generate detailed reports that include line coverage, functional coverage, and whatnot. Basically highlight how like which files need more coverage, what's the percentage of these coverage, etc. And Suricata has the code tool integrated with them. So if any one of you has ever made a PR in this code base, you will see that at the end of the PR, in one of the CI checks, the code check runs, and you will get a code report like I have here on the right side of the screen for your specific PR. So this code report will tell you that okay, the contribution you made in this PR basically decreased the code coverage by this percent or increased the code coverage by this percent. So here are some the flags by which these coverages organized is also available. So they also have a view of getting the coverage by the type of tests that execute. So the Suricata verified tests, unit tests, and then the percentage. So when I started working on this project, me and my mentors, they basically analyzed a few files within the code base, and they were assigned to me based on what is how much coverage they need and which files need more coverage. So they had a specific criteria of how much coverage each file should have, and if it is less than that criteria, then it was shortlisted for improving the coverage. So once I had those files, next thing that I had to do was to analyze how can I improve their code coverage. So basically which portions of code are not covered, and how I can increase them. So basically it was mostly about some rule keywords that were not covered, and then to cover those I had to write Suricata verified tests for those specific keywords. And once I wrote Suricata verified tests for those rule keywords, I like the expected output was that it will increase the code coverage. But to be able to be at a point where I can visualize that, like visualize the output of my tests. So once you write a Suricata verified test, you run it over the Suricata code base, it passes. But to be able to actually confirm that it is increasing the code coverage as intended, I had to find a way to do that locally, because the tool is integrated in GitHub. So if you make a PR, you will make a PR and it will get accepted, and then it will be part of the code coverage report. And this is I'm talking about the tests, not about the PR for the code. Like, you will see code coverage reports for your PRs, but if you write a test that improves the code coverage, but to actually see that change, it has to be merged in the code. So for that, me and my mentor, we sat and then we tried to find a way of uh, generating this code coverage locally, and that's how we found uh, we found a way to generate the code coverage locally using some LLVM commands. And for this to work, first Suricata has to be configured with some flags. So when you build Suricata for the first time, or for any of the tests, or whenever there is a change, there are a bunch of commands normally that are passed. Like, one is the configure command. You have to configure it with some flags. If you want to have unit test, then you have to pass the enable unit test flag, and then you have to build the code, and then you do whatever you want. So similarly, to build Suricata with the ability to generate coverage reports locally, it was some flags needed to be passed, and these flags, I have highlighted these. So first we have to configure Suricata with these flags, then we have to build it, and then now the code base is ready. So whatever test you will run after this, it will basically contribute to the coverage. And finally, for example, in the third bullet, I have run a TLS test. So finally, when I will generate the coverage, the last two commands basically generate a local directory on your PC, and this directory will contain all the coverage reports that will be generated file-wise. So in those files, you will be able to see how the test contributed to the coverage. And this is the in the final bullet, basically you have to specify a path, and then you specify the name of the directory, and that's how it generates. This is a representation of the directory. This is the report directory, and the files are basically listed, and against each file the functional coverage, line coverage, region coverage is mentioned. So if you see, the red represents that it has very, very low coverage. These are these are files within the Suricata code base, which I basically I'm showing here, and this is before any tests are run over them. And the files with the 100% percentage basic indicate that some tests were run, and after those tests, these files are covered. Now I'll be moving on to a demo of how the code coverage changes. So I have already built Suricata, or I've already configured Suricata with code coverage functionality, like I have mentioned in the previous steps. So here we are already at a point where I have configured the Suricata, and then this coverage report is generated here. But since I have not run any tests, everything is 0%. Basically, it says nothing is covered yet because there are no tests are run. So for the coverage report to change locally, you have to run those tests. So again, I will be focusing on just one file, the detect TLS file. And then after running those tests, we will be able to see how the coverage is changing. I have highlighted the TLS files. Now I'll be just running the tests and then generating the report again. So because the old report has rendered, every time you run those tests, you have to render the report again for the coverage to take effect. So now I'm rendering the report. Now, as you saw, some of the files changed, their coverage changed to green and yellow. So this basically shows that their coverage was changed. Some of them got to 100% and other was less. This basically shows that some portions may still be not covered. And if you open any one of these files, this is also available, this view that you are looking at, where all the uncovered lines will be highlighted as red, and then you can jump to any of it and then revise your tests based on this. So this basically gives you a nice way of viewing the coverage and the changes that your tests are contributing to before you commit them as a PR. With that, like I've come to the final part of my presentation. That was it about the code coverage and generating things using LLVM commands, and this is specifically for the Rust and C part. And then with all of this that I just said, this makes me really happy to be able to see that I was able to understand all of this throughout my journey with OISF and then with Outreachy, and I was able to actually write some code and contribute, which was like the biggest fear that I was not able to overcome during the many past years. And then I also got another major learning outcome is that I got familiar with open source world and open source contributions, because if you are someone or who has worked with any open source community, it is very overwhelming when someone joins there, because every community is different, every code is different, they have their own ways of managing the code, they have their own ways of talking to the community. Like for example, when I was trying to or contribute to another one of the community, and they had IRC channels, and even to this date I do not understand how IRC channels work, and they, like, if I read IRC I just close the tab and everything, because it's I don't understand it at all. So this is another thing that I'm now at a point that I am able to navigate my way around this these open source projects. Then another very important thing that I learned is making good quality PRs. OISF has they have very strict and nice standards for the code they would accept. So it would take a lot of versions of one PR before your PR is at a level where they will accept it. And it's not always about the code. So it's not like you're not writing the right stuff in the code. It may be about many other small things, and they have a very specific criteria and very strict criteria. So that helps you basically understand what goes into a good quality commit. Like when even now my internship has ended, it has been a few weeks, now I'm writing code and I'm committing that even to a personal repository. I just because it has been a habit of during the internship, I just think about prefixing it with the right keyword, adding the right body, and then I'll be like, okay, the body is too long, it shouldn't be that way, because it's like, okay, what would Juliana say if she's looking at this, and how what kind of comments Victor will leave on my PRs if these are the kind of PRs I'll be making. So this is another thing that has become a habit of mine. So that is another great thing. And then another outcome is the connections that I have made. The community has gone above and beyond for me every point, even like at every point, if they saw that I needed something, they have reached out to people outside of OISF, outside of Outreachy to help me. And then finally, Juliana mentioned this too, I was able to start a blog, and this is another fear of mine. I get really, really scared to put my words out there. And even to this day, I just like to imagine that no one is reading them. So that's the only way I'll be able to write. That's all from me. Uh, these are some resources and then some reference links. And I would like to mention the past webinar by Sam and Madhupe again, because this has really, really helped me during the contribution phase and even the internship phase. I used to go back to this webinar multiple times to understand about frames, to understand about Suricata verified tests and what are they. So this is another helpful resource. Thank you so much. Let me know if you have any questions.
Thank you, Halima. That was great. I think you can leave maybe the resources showing on the screen.
Okay.
People were celebrating what you shared with us. I don't know if anyone has any questions. It's great to see the journey and how much you have grown. And I laughed when you said that now you have our little voices in your head. When you submit a commit, even for your local repos. That's a good outcome, I guess. Folks, do you have questions for Halima? Feel free to share in the chat. We'll still have some time before the scheduled time is over for the webinar. So Madhupe is also thanking you for sharing your work, which is nice. Kale has said you did a great job, and and it's true, we are delighted to have had you as an intern with us. Philip has asked, sorry, Philip, if the slides will be available. Yes, we will put them a link to them when we publish it on YouTube. It may take a few days for us to edit things so it can be ready for YouTube, but they will be there. More questions? One thing that I would like to say is that we already have our next webinar scheduled. So if you are following us on Eventbrite or on Twitter, you will know about that soon, but it's about DPDK, which is one of the big favorites and everyone wants to know more about. So next month, Lucas will be talking about all you have to know about Suricata and DPDK. Philip has asked, which areas the code deserve more coverage? Do you know that from the top of your head?
No, actually, I was mostly working on a file-to-file level. So, and then specifically in the C files I was working. So there are still a lot of C files that had low coverage, but yeah.
But I believe to give more answer to what Philip asked, when the reports that Halima showed in the PRs, you can check the code coverage by coverity, and then you will be able to see all the files and get a bigger view of how things are, the big picture. So that is available for anyone. You can also create an account to have more details, or you can follow the steps that Halima has shown so you can see that locally. But mainly, I know that some of our role keywords could get more attention in terms of coverage, from what I remember. Yeah, Victor just shared in the chat a link where anyone can check which areas of our code deserve more love in terms of code coverage. Do we have more questions? Victor is saying that it helps to log in to deal with the limits from GitHub to showing all the code. So that's why logging into the code call helps if you want to see the report for coverage. Do we have more questions? Anything? Anyone has a joke to share? A bad one. I only know bad jokes. So this has been a great webinar again. Jason and Victor, who were also mentors for Halima, are expressing their celebration for the webinar and her work. As the OISF spokesperson today, I would like to once again congratulate you on all your work with us on your journey. You know that we are always wishing you good things, and we want to know all the big things that will happen in your life and your next big steps. For the Suricata community as a whole, as I said, be sure to check Eventbrite for our next webinar. Check Twitter as well, as we always share our news there. For the possible Outreachy applicants who may have been watching this, there are some interesting key points here, and it shows that there's always a space for you to learn if you keep showing up, as Halima said. Try to be consistent, find a community that works for you, try to read the guidelines. This is always important if you are an Outreachy participant, or just if you are trying to contribute to Suricata or any other open source community. Do check the documentation and how things are done for that community. This will help a lot when you are registering your first contributions. I don't know if anyone has anything else to say. Do you want to share anything else before we close this for today, Halima?
No, I don't have anything else. Just wanted to thank you guys for taking out the time, and all of the participants who are here to hear me talk for this many minutes. Thank you so much.
Thank you as well. Once again, your internship is over, but you made time to be here with us today. It's not easy, folks, to be talking for so long. Usually Outreachy webinars by the Suricata community are much shorter, and we share the time between two interns, and Halima has been able to fill all the space with her knowledge and journey and experiences. That is awesome. Big round of applause to you, and I hope to see big things from you soon. Folks who joined us today, thanks a lot for your audience and your attention with us. Follow us on Twitter, Eventbrite, YouTube for knowing when we publish new webinars there. And that's it for today. Have a great day, evening, afternoon, wherever you are in the world. Thanks a lot, folks. I'll stop recording, and this is it. Thanks.